Section 5.2, example 4 on page 350. We have recall that a over b divided by c over d is equal to a over b times d over c, where b does not equal 0 and c does not equal 0 and d does not equal 0. When you divide rational expressions, first rewrite the quotient as a product using the reciprocal before dividing out common factors. So for example 4, we have what is the quotient x squared minus 25 over 4x plus 28 divided by x minus 5 over x squared plus 9x plus 14. Technically, we can factor everything and then flip our second rational expression, or we can get rid of the division and flip our second rational expression first so we don't have to worry about forgetting that step, and then we can factor everything. So let's do that first. So again, all we are doing is replacing the division with multiplication and then flipping our second rational expression. Now let's take a look at which ones we can factor. X squared minus 25, the x is squared and the 25 is squared. This is a difference of squares, so that can be factored. You can also use the quadratic formula or the x box. 4x plus 28, those both have a common factor that we can factor out. X squared plus 9x plus 14 is also a quadratic, so we can use the quadratic formula, x box. And then x minus 5 is a binomial, but the x and the negative 5 don't have anything in common. So that's actually the only one we're not going to factor. So reminder that we have difference of squares is a squared minus b squared becomes a plus b times a minus b. X squared is written as a perfect square, so we keep it as x squared. 25 is not written as anything squared, so we can rewrite that as 5 squared. This then becomes x plus 5 times x minus 5. So that is our first numerator. Next, we have 4x plus 28. Notice we can take a 4 out of each of these terms, and that leaves us with 4x over 4 is x, 28 over 4 is 7. That is our first denominator. For our next numerator, x squared plus 9x plus 14, we have a quadratic with a coefficient of 1 for a. So again, we can use just the x. 1 times 14 is 14. B is 9, so we need two numbers that multiply to 14. 7 times 2 is 14, and add to 9. 7 plus 2 is 9. So this tells us we have x plus 7 times x plus 2. That's going to be our second numerator. And then our second denominator was already as factored as it could be. So now we want to check to see if we have any common factors in the numerators and the denominators. So in the numerator, we have x plus 5, x minus 5, x plus 7, and x plus 2. The denominator also has an x minus 5 and an x plus 7. So the x minus 5's on top and bottom, and then the x plus 7's on top and bottom can be eliminated because together they equal 1. This leaves us with x plus 5 times x plus 2 over 4, and that is your final answer. So here's a little summary of the steps that we took in this problem. First, you're going to switch the division symbol to a multiplication symbol. So here we had division, now it's multiplication. Then you're going to flip the second rational expression. So here we had x minus 5 on top, now it's on the bottom, and then we put the denominator up in the numerator. Then we're going to factor, and the last step is to simplify. All of that work is also written out with explanations on the next slide. And now I would like you to divide x minus 1 over x plus 4 divided by x plus 3 over x plus 4.